Hello, everyone, and welcome back to our APES flipped classroom. We're continuing Unit 4, which is all about Earth systems and resources, and we're continuing talking about weather and the sun and how it's all related. So we're going to talk about solar radiation and the seasons of the Earth. So the first term we're going to define is this thing called insolation. Insolation, not insulation. So we're not talking about the stuff that keeps your house warm or cool, but we're talking about the amount of solar radiation that is reaching an area. And this is measured in watts per square meter. This is the energy from the sun. And it's a way for us to measure that energy. And so we're going to talk about incoming solar radiation being our main source of energy and all of the different things that impact the amount of insolation at each point on the Earth. So there's really two main things that solar intensity depends on. One is the angle, and that is how directly the rays strike the Earth's surface. And the other is the amount of the atmosphere that the sun's rays have to pass through. And obviously those two things are related at a more oblique angle. That means that it is going to have to pass through more of the atmosphere, which means that it's going to lose some of its energy as it's passing through the atmosphere. It's going to lose that energy to the atmosphere rather than to the surface of the Earth. But the angle also impacts the amount of area over which that energy is spread. So these rays come in with the same energy. More is dissipated as it goes through a higher amount of the atmosphere, and that initial energy is spread over a larger area at high latitudes. So what that means is that the equator receives a higher insolation than our higher latitudes. So just a different image, you can see here we have the same amount of light, but it's being spread over a large surface area. Same amount of light being spread over a small surface area. So obviously this is going to be more intense. We're going to have a higher level of insolation, higher amount of energy per unit area if we have a smaller unit area. So 400 watts per square meter, 200 watts per square meter. Season also is going to impact that insolation, that solar intensity. We remember that the Earth is tilted. It's at about a 23.5 degree angle. And as the Earth rotates or orbits around the sun, the tilt on that axis is going to change the angle at which the sun's rays impact the Earth. And this is what causes our seasons. That tilt stays the same. And which side of which hemisphere of the Earth is therefore more directly exposed to the sun changes as we orbit the sun. When the hemisphere is tilted towards the sun, that hemisphere has longer days and more direct insolation, and so it has a higher intensity of insolation. When it is tilted away from the sun, then we have shorter days and lower intensity. So when it's tilted towards the sun, it's summer in that hemisphere. When it's tilted away, it's winter in that hemisphere. And then obviously we have the fall and spring in between. So we have two solstices. We have a June solstice, which is the longest day in the northern hemisphere and the shortest day in the southern hemisphere. And we have the the December solstice, which is the shortest day in the northern hemisphere and the longest day in the southern hemisphere. And then the equinox is when the north and the south hemispheres face the sun equally. That is both March and September. Okay, so in the December solstice, the southern hemisphere reaches its maximum tilt towards the sun. It is the longest day in the southern hemisphere. It's the start of their summer. It is the shortest day in the northern hemisphere and is the start of our winter. As we progress from winter into spring, we reach the March equinox. At the March equinox, the equator receives the most direct insolation. Northern and southern hemisphere both get 12 hours of sunlight. And this is spring in the northern hemisphere and fall in the southern hemisphere. As we move from spring in the northern hemisphere into summer, our days get longer as that tilt brings the northern hemisphere closer to the sun. We reach our maximum, not closer, sorry, more tilted towards the sun, so that we have more direct insolation. It's definitely not closer. This is the longest day in the northern hemisphere. It's the start of our summer, and it's the shortest day in the southern hemisphere, and it's their winter. And then again, as we move towards fall, we return to the equator having the most direct insolation, and it's fall in the northern hemisphere, spring in the southern hemisphere. So it's the tilt of the earth that is responsible for the seasons. It is responsible for the changes in the length of the day. And that's all because of that angle of insolation. Be careful, it's definitely not about distance from the sun, okay? In fact, in the summer, we're a little bit farther away from the sun. So it is about the tilt, not the distance. Okay, other things that impact our climate are things like albedo, and we've talked about this very briefly, but albedo is the proportion of light that is reflected by a surface. So if you have a surface with high albedo, it reflects more light, it absorbs less light, it tends to absorb less heat, and therefore is colder, acts as an insulation from heat. Surfaces with low albedo, on the other hand, reflect less light, they absorb most of the light, and they absorb more heat. So we talked about this initially when we talked about positive cycles, that when the ice melts, that decreases the albedo, which allows the water to absorb more heat, which causes more ice to melt. And so we have a positive feedback loop. Obviously, albedo, that reflectivity, is going to affect surface temperature. So when sunlight is absorbed by a surface, it heats up and it gives off infrared radiation. So those areas with lower albedo absorb more sunlight. That means they get hotter. And this contributes to a phenomenon we call the urban heat island, which is that urban areas have huge amounts of concrete and dark surfaces. And because they have extremely low albedo, that means that they tend to absorb more heat. And so urban areas are hotter than the surrounding rural areas. And so we get this urban heat island effect. Polar regions and mountaintops tend to be colder because they have high albedo because of snowcap or glacier or ice. Okay, so your practice today is to identify which season is taking place in the northern hemisphere in this diagram. And I want you to describe how the tilt of the Earth's axis is responsible for Earth's seasons. As always, if you have any questions, let me know. Look forward to seeing you soon.